Good afternoon, everyone. Welcome and thank you for attending the Managing Data Between CAD and GIS session. Our speaker today is Kenton Yearick with Mazer Consulting. Kenton is a GIS technician specializing in oil and gas utility GIS applications and land-based data using Esri products. If you could hold your questions to the end, or feel free to enter any questions in the chat box, you can. We'll get to them at the end of the presentation. And with that, take it over, Kenton.
Awesome. Thank you, Richard. Again, my name is Kenton Yearick, and today I'll be talking about managing data between CAD and GIS environments. Today, the topics I'll cover are data management workflows for integrating CAD to a GIS environment and vice versa, a GIS to a CAD environment. These practices will explore techniques in both CAD and GIS software to set the user up to perform spatial updates to the data. At the end and throughout the presentation, I'll highlight some of the challenges of maintaining data across CAD and GIS. Most importantly, keeping the data accurate and accessible to the end user or client. The presentation in general will have a focus on the engineering industry and how both applications are integrated. Up first, I'll talk about CAD data requirements and how CAD standards can impact and improve the level of detail when migrating to a GIS. Spatial information. Knowing what coordinate system the CAD data is in is very important and is the main concern when migrating to GIS. This brings up a good point of having a solid relationship with your CAD tech and engineer, or simply asking the CAD user for the correct coordinate system. A projection file or a PRJ file must be present in the folder directory to properly place the data in GIS. This projection file is a text file that contains spatial information regarding a specific coordinate system and its parameters. If the projection file is not present and the knowledge of the projection is unknown, georeferencing will have to be the resulting option. CAD standards are also important, and having a predefined layer type allows for a seamless understanding of what the CAD data represents. For example, if the layer type is not implemented into the drawing initially, all line types will be the same and could pose difficult for the CAD or GIS user to understand the differences between assets. The picture on the right details how a right-of-way center line differs from the surrounding contours and assets. Lastly, version compatibility. Version compatibility is very important when you migrate between different software. With the partnership of Autodesk and Esri, this knowledge is much easier to find. Esri provides the compatibility information on their documentation pages. For an example, ArcMap 10.6 will not read or write DWG files that are 2018 or higher. This is useful information to know before migrating your data. Next, let's take a look at what a standard CAD to GIS workflow would look like in ArcGIS Pro. First, we will need to add our CAD data to the map. Then we will need to define a projection to that data. If our data is not in the correct projection and correct location after the projection is defined, the data will then need to be georeferenced. After our data is in the right location, we can use the Export to CAD tool to get our data into a GIS-friendly format to be able to edit and share the data. Now let's take a look at each step in more detail. Firstly is adding CAD data to a map frame in ArcGIS Pro. This can be done a few ways, but I'll highlight two of the most common methods. For the first method, in ArcGIS Pro, you can navigate to the map ribbon, and within the layer group, you'll find the Add Data option. You can navigate to where your DWG is located and simply add it to the map. As another option, you can use the catalog pane and navigate to the drawing. You can simply right-click and add to current map or a new map, or simply drag and drop the drawing into the map frame. Defining the projection is next, and knowing the coordinate system of the CAD data is very important. A projection file will be in the same folder directory as the CAD data. The PRJ file is a text file containing parameters for a specific coordinate system. These files can be applied in ArcGIS to the AutoCAD data or by downloading through Esri documentation pages. If a universal projection file exists in the directory, the projection information will be taken from that universal projection file and applied to the CAD data. For example, I have 4 CAD files in the same projection, and I can use that PRJ file and name the PRJ file esri_cad.prj, and it will apply the coordinate system to all CAD files in the projection. If there isn't a projection file in the directory, the data will result in appearing near or at what I call null island, or better known as 0, 0. As this island might seem like a great place to take a vacation, it's not where data should reside. To correct, apply a projection in ArcGIS by using the Define Project tool. If the projection is unknown and the CAD or engineer doesn't know the projection of the data, the best practice is to apply a projection before georeferencing. Georeferencing will need to be performed based on several underlying issues. One issue could be that the CAD data was drawn without a projection assigned to the data prior to drawing. Secondly, the CAD data might have been drawn in the correct coordinate system, but the coordinate projection information wasn't relayed to the GIS user. When georeferencing CAD data, the data can be moved, scaled, or rotated to the correct location. Another option is to create control points. Control points define the source and destination of a CAD dataset. A maximum of 2 links are permitted. Each link comprises of 2 points, a from point at a known location on the CAD dataset and a to point at the intended new location. After georeferencing is complete and saved, a WLD file is written, or better known as a world file. This adjustment method maintains the aspect ratio of each CAD drawing and prevents skewing in the X and Y axis. This method prevents warping, or what we know as rubber sheeting, to the data, and maintains that high level of accuracy from CAD data. Lastly, you can use the CAD to Geodatabase tool to import contents of 1 or more CAD datasets into a Geodatabase format. This tool will merge feature classes and create an annotation subclass for each text layer in a CAD file. The input parameters can accept CAD data from multiple formats: DWGs, DXFs, and even DGNs. The output is a geodatabase containing all CAD elements. The user can now edit, maintain, and publish to either the public or within their ArcGIS organization. Now we will go through a quick demo on bringing in CAD data into the GIS. The data used in this demo was accessed and downloaded through Esri training websites, so this data can be publicly available with an ArcGIS Online account. Now I know this data should be in Redlands, California, specifically on the Esri campus, and more specifically, Building L. In ArcGIS Pro, we can use the catalog pane to navigate to where our DWG is located. Once the drawing is in the map frame, we notice at the top right, an unknown coordinate system dialog box appears. This means there is no PRJ file or projection file associated to the CAD data. If we zoom to the CAD data, we notice it's in the ocean just off the coast of Africa, near or at Null Island. We will need to define a projection to this data. We can drop down the group layer, select the CAD feature class, select the CAD layer ribbon, define projection, and navigate to the known projection that the CAD tech told us. I know this is in Redlands, so we're going to use the California state plane. I navigate to the state plane and apply the correct coordinate system. By selecting OK and Run, a PRJ file will be written and applied to the CAD data. Now if we zoom to our data, it should be in the correct location. We notice it's not. This is because the CAD data was drawn before a coordinate system was assigned. We are going to need to match the map frame coordinate system to the CAD data. This is a best practice. We notice it makes the CAD data closer to the correct location. We're going to use the bookmark and go to Building L on the Redlands campus. We can navigate back to the CAD layer and select Georeference. We can use the Move to Display option to display our CAD data. We can now add our control points by simply selecting the CAD data first, which is our 2 point, and selecting the spatial location on the base map, which is our from point. Remember, only 2 control points can be applied to a CAD drawing. By selecting Apply, and if we zoom out, we see its location is correct. Once we select Save, a world file will be written and understood in the ArcGIS software. We now need to convert the CAD data into a GIS format. We can use the CAD to Geodatabase tool located in the Geoprocessing toolbox, navigate to our CAD file, select OK, and we notice that the spatial reference is applied and understood. We can leave the output as default and select Run. Once the tool is complete, we can navigate back to the catalog menu, navigate to our output, and add it to a new map. We can now see that the CAD data has been transferred to a GIS format. It can be edited, shared, and published to the end client user. Now we will briefly go over a GIS to CAD workflow. A typical GIS to CAD workflow is a much simpler process compared to bringing CAD data into GIS. Either shapefiles or feature classes from a geodatabase can be exported to CAD easily with the Export to CAD tool. In the Export to CAD tool, after importing GIS features, you can then specify the output CAD data type. This gives the option of different CAD types such as DWGs, DXFs, or DGNs, and versions of those software. In the Environments option, you can specify the output coordinate system to that drawing. You can open the resulting CAD file in your CAD software either as its own drawing, or it can be brought into existing drawings by using the xref command. Now let's discuss some of the common issues when working with CAD data and GIS data. I've listed some of the more common issues when migrating and maintaining CAD data and GIS data. Firstly, as I mentioned many times through the presentation, the projection is the main concern when integrating data between systems. Getting the spatial information up front and having a solid communication with the CAD technicians can allow for cost savings to projects. Next, knowing and understanding symbologies and how they differ between softwares going from CAD to GIS or GIS to CAD. Additionally, knowing and understanding symbologies across different disciplines can allow for the end user to have a better understanding of the data and provides a clear story. This rolls into knowing and understanding CAD standards. CAD standards can vary between companies, but should be communicated with all users that will interact with the data. Layer types are an example of what could be standardized in an organization to create a seamless transition between a CAD user and a GIS user. Migrating CAD to GIS workflows are always changing. I've listed a couple of new workflows and plugins for Autodesk and Esri software. ArcGIS for AutoCAD is a free plugin that simplifies the way you share and synchronize GIS data content between AutoCAD and ArcGIS. You can connect to GIS data and edit geographic features within AutoCAD and then use them to navigate the drawing. Additionally, Connector for Autodesk was introduced to versions 2020 and higher and is located in the Insert Ribbon tab within a Civil 3D. This option allows for a CAD user to connect to an organization's geodatabase to be able to utilize the GIS data within CAD, while also having the ability to edit and push edits back to the GIS dataset. This can be very powerful. In conclusion, please feel free to reach out to me directly on LinkedIn or by email. I am more than happy to answer any additional questions you might have regarding GIS and CAD data. And thank you for your time, and I open the floor to any questions.
Hello.
Hello?
Sorry, guys, I had a headphone issue there. Can you hear me okay, Kenton?
Yeah, I hear you.
All right, great. Yeah, we have some Zoom group chat here. We have a couple of questions, or let me get these questions going here. Starting up at the top, Patty Dukes has a question that says, can you drag and drop 2017 CAD drawings?
Yeah, that's a great question. ArcGIS Pro reads and understands all versions of CAD data and CAD versions. So yes, that's correct. You can utilize 2017 versions in ArcGIS Pro.
All right, I have another question from Julia H. What about MicroStation? Any connectors for that type of CAD file?
Good question. Yes, the CAD data or the GIS data can be written and exported to a DGN file. And within MicroStation, you can attach that reference. So yes, it can, I don't know about a connector within MicroStation, but I know that you can bring in DGN files created from GIS data into MicroStation.
Awesome. Okay. And is it, this is from Peter Erlenbach. Is it possible to connect to a file geodatabase feature class within a CAD platform?
That's a great question. Yes. I kind of talk about it at the end with the plugins. So if you were to use any of the Autodesk plugins, ArcGIS for Autodesk or Connector for Autodesk, you can actually connect directly to that geodatabase within your ArcGIS organization if you're utilizing Enterprise or if the data is stored within your internet or within your network.
Gotcha. This is from Connie Cramp. Is there an easy way to handle text from CAD?
That's a great question. So CAD data is understood as an annotation within CAD, or within CAD, text is understood as annotation. That annotation layer is converted to a point layer within ArcGIS Pro and is contained within the field or attributes and can be seen using the label or shown as labels and exporting those as annotation layers within ArcGIS.
Right. Then I have another question here from Chris Contreras. Can DXF files be used from open source CAD platforms?
That is a great question. And I do not know the answer off the top of my head. And I'm curious myself. If Chris would like to reach out to me by email, we can talk more about the question in more detail.
Got it. All right. I think that looks like that covers all the questions in the Zoom group chat here. Awesome job, Kenton. Great information. There's a poll on everyone's screen now. Please fill out the poll. And I think there's some additional information in the Zoom group chat here for the wrap up and door prizes. I'll let Bailey touch base on that. And thank you guys, everyone, for attending.
Yes, thank you so much.
Thank you so much. Please click the link in the chat to join the Day 3 wrap up and door prizes session. Take care, everyone.